Good morning, dear students. Okay, very good morning. Today, let us continue yesterday's concept. What? Optical instruments, where we have to study nature of image form, and magnification produced, and also magnification produced. Okay. First, let us take simple microscope. This simple microscope is also called what your reading lens, or it is used in laboratory as a magnifier also. It is used in biology lab also as a magnifier, also as a reading lens. Here, what we have to study? We have to study nature of image formation and expression for magnification. Remember what we have to do? We have to simply write expression for magnification. No derivation is asked. Okay, usually they are not asking any derivation. Let us go directly write expression and remember those expressions. Okay. What is near point? As we discussed yesterday, near point is the shortest distance. From which a ray of light enter through our eye lens and produce image on retina. For normal view, it's around 25 centimeter. Okay, we represent this near point as a D, capital D. Okay, sometimes it's also called least distance or distinct vision. Okay, how to draw this? Let us consider a prism with the principal axis. Okay, let this be F, and let O represent optical center. At a near point, when object is placed, note at near point, probably for 2 months. You will get this question for 2 months only, not more than 2 months. Okay. When object is placed between F and O, we know what's the nature of image form. Image is formed by the side of your object. First thing, it is enlarged, erect, and virtual. We can use this this position of lens for magnifying objects or as a reading lens. Okay, simple. Now, second image, let us consider any two rays. Better. First ray, I will consider a ray which is parallel to principal axis. After incident, we will pass through second principal focus. Okay, a second ray which is incident on optical center will travel without any deviation. Without any deviation. This ray, second ray, which passes through optical center, will travel without any deviation. Travels undeviated. It travels undeviated. Okay. How to construct image then? Simple. Let us draw these two rays back. Okay. And this one. Okay. Somewhere here they made. Okay. here. Visible, correct? We get enlarged image of the object. Enlarged image of the object. This distance is nothing but object distance. I mean image distance, sorry. Distance is nothing but image distance. Of course, this distance will be your object distance. This position is also represented by D. Why? Why? Because D is the least distance of distinct division. This distance is represented by D. Here V is equal to D. V is equal to D. Of course, it's minus D. Your sign convention, you know. This side and ray traveling this way. This is the direction of ray, and you are measuring in this direction. Of course, V is equal to minus D. Okay, one second. Okay. See, this lens key, or we have to consider only thin lens. It seems to be thin, but it is thin lens. For thin lens, we have this formula. What? 1 by V minus 1 by U is equal to 1 by F. Say equation 1. If you are interested to calculate magnification produced, what is the magnification produced by this system when object is placed between F and O? I mean, O means optical center here. Okay, you can write it at C also, no problem. I am taking it as a O. When object is placed between F and O. Okay, then your image will form by the side of object which is erect and virtual. So magnification, we know magnification is defined as, in case of lens, it is a ratio of height of image to height of object, or in terms of V into, it is equal to V by. We know this, correct? You know this. We have derived all these things, correct? Now, I write somewhere here M is equal to V by Q. From this equation, see, 1 by U is equal to 1 by F plus 1 by V, correct? Correct? 1 by U is equal to minus 1 by U, actually minus 1 by U, okay? Minus 1 by U. So it is 1 by F minus okay. Right in this way only. This is 1 by minus 1 by U, 1 by F minus 1 by V. Or 1 by U is equal to 1 by V minus 1 by F. Okay, now fine. If you put this, say equation 2, okay, if you put this in this equation for magnification, M is equal to V by U, say equation 2. This equation for magnification, correct? In case of lens, this equation for magnification. So now I can put value of 1 by U, that is V into 1 by U, correct? Somewhere here, let me write. See here, M is equal to V into 1 by U. We can write this equation in this fashion. We can write this equation in this fashion, no problem. Or V into bracket. From equation 2, in place of 1 by U, let me write 1 by V minus 1 by F. No problem. or here let me write magnification is equal to V by V minus V by F. Correct? Correct? Visible. Fine. Now, M is equal to 1 minus, okay. In place of V, let me write this, where V is equal to minus 3. In this case, this distance represents this least distance of distinct vision, or simply what? This distance is nothing but your near point. Okay, I can replace this V by D, and hence there is minus also. This will be equal to V by. This is the expression for this is important expression. See, this is important expression. M is equal to 1 plus D by F. This is an expression for magnification produced when object is placed at a near distance, or it is the expression for magnification for an object in case of least distance of distinct vision. Please remember, this may appear for 1 mark. Write the magnification in case of simple microscope when our image is formed at near point or least distance of distinct vision. Okay, next. Second. We have done this, correct? Hope you understood, right? Remember this. Remember this equation we are using in next equation. I will tell you where we have used this. Okay. Okay. Now, second case let us consider at infinity. When image formed at infinity. When image formed at infinity. Same thing, let us consider a thin prism lens. Let this be F. Okay, F. O. Okay. Now, let us keep our object exactly at F. When object is placed exactly at F, focal length, principal focus, then what we observe? We observe our image is formed at infinity. Our image is formed at infinity. What is the nature? Inverted, very much enlarged, but real. Okay, let us consider first way as usual through second principal focus. A second way through optical center. If you check what we have, image is formed at infinity. Image is formed at infinity. Please remember very simple diagram. Okay, no problem. Here magnification, let's write directly. Question, take one. Draw image formation in case of simple microscope when image is formed at infinity, and write the magnification. Here magnification is given by M is equal to, let's go again, M is equal to F by D. Please remember this directly. Please remember this directly. In case of lens, simple microscope, when image is formed at infinity, magnification is given by M is equal to F by D. Please remember it directly. No direction is required. Okay, m is equal to FYD. M is equal to FYD. Okay, done. Okay, second optical instrument to be studied in this chapter is compound microscope. Where we use compound microscope? Microscopes, of course, in biology lab. Correct? In labs, everywhere we use. Okay, what is compound microscope? In compound microscope, okay, of this shape, we use some slides, put some specimen, or already there are some specimen, and we have two lenses. Remember, one towards the object, one towards the object, other where we have to see through the second lens, where we see the object. So there are two lenses. First lens is called, which is near to object, is called objective. It is called objective. Second lens, which we can adjust, is called eyepiece. You know these terms of eyepiece. Correct? There are two lenses. First lens is called objective. Second lens is called eyepiece. Okay. What is the nature of image form in case of compound microscope? Okay. Let us consider a lens, a principal axis. Correct? An object is placed in front of this first lens. Let us consider rays to construct an image. Remember, this object is placed beyond F. This is F. This is O. This is beyond F. Beyond F. Okay. This is the second principal focus. Okay. Now let me consider this point is not required. Anyway, this is beyond F. I write F only. A ray, okay, straight or not straight, correct? Once again, forgot to bring the scale on those things. Okay, this is the ray. Here we observe what? Formation of image. Formation of image. I will draw neatly now. One second. Yes. Chalk pieces are not very supportive. Okay. Now, this is somewhat good. Yes, this is the point. Okay? We know, I will mention this point as a only. Second principal focus. When object is placed between OF and F, your image is formed beyond OF. What is the nature of image? It is enlarged, inverted, and clear. In this case, real image is formed. Real image is formed. This lens is called objective lens. This is object. This lens is towards the object. Hence, it is called objective lens. It is called objective lens. Okay. Let this be what we call image distance. Now, this length will be focal length of this lens. Focal length of this lens up to this point, right? So, focal length of this lens or objective FO required. I am writing it as a FO. Now, let us take one more lens here. Okay. Which at a distance, this lens is called, of course, fine. This lens is called eyepiece. Eyepiece. When ray of light incident, okay, if this is AB, then this will be A dash, B dash. If this is a height of object, this will represent what? Dash, height of an image. We know once again these rays are get refracted. This is a portion of your eye. This is portion of your eye. Or eyepiece, you see through eyepiece. Where exactly is the object? Now, this distance is if exactly equal to focal length of second lens eyepiece, then what we observe? Okay, I will try to draw without scale. Okay, let me trace back those rays. Okay, somewhere here, I can trace it back also, no problem. Yes. Okay, this distance is fine. Okay. Somewhere here, very much enlarged virtual image is formed. See. Okay. This is not very straight. Okay. Once again, lack of scale. Okay. We'll draw. Okay. Right? Fine. Let us imagine we'll meet here. Here it is. S. See. When object is placed, when object is placed exactly at a distance of focal length of this eyepiece, then this image from this lens acts as an object for second lens. Let me repeat. Please listen carefully. This is initial your object. Correct? When object is placed in front of an objective lens beyond f, a real inverted image is formed, which is bigger in size, inverted in clear. If your second lens, say eyepiece, is placed at a distance of f from this image, now this image will act as object for your second lens. If it is f at a distance of f, definitely it is as if you are placing an object at position f. Simple microscope case. First case we have studied simple microscope. In some simple microscope, when object is placed at f, your image is formed at infinity. Here too, if this object is placed, this image formed is in between f and o. What is the principal focus of this lens and o is objective, then your image will form at near distance. Your image will form at near distance. It is enlarged to the side of the object and virtual. Hope you understand. Hope you understood the concept. No? Let me repeat one more time. Okay. This is image formed by first lens. No problem. This image acts as an object. This image acts as an object for second lens. If this image which acts as an object is in between f and o of the second object, f and o of second object, what is f? Principal focus. What is o? Optical center. Then virtual image is formed at the side of the object only, which is very much enlarged. If this image is kept exactly at f, this image which acts as object for second lens is exactly at f, then your image will form at infinity. Your image will form at infinity. Here too we have two cases, at near point, at infinity. If this image acts as an object for second lens and its position is between f and o, then what we observe? This case, what have we done? What we observe? We observe virtual image which is enlarged. Now this distance will be d for us. D. Now this distance will be d. Suppose by chance, suppose that you are keeping this lens exactly distance of f, then your image will form at infinity. Same, this second part is like your simple microscope. Second part is simple microscope. Okay, you understand? This object is which is initial image of first lens, acts as, okay, is if it is at f, image will form at infinity. If it is between f and o, image will form at near distance. Image will form at near distance. Okay. Here magnification is due to, see, magnification due to objective written as FO, visible. Okay. I will write here. Here, magnification is due to objective into magnification due to what? Eyepiece. Okay? This is eyepiece, correct? Okay. Here, magnification in this case is equal to m is equal to m objective into m eyepiece. Correct? No problem? Okay. One last time. This is very important calculate, very important to mention. Very important. Already 2 times for 2 marks usually is asked 2 to 3 marks. Okay? And 2 times already asked in exam. Okay? Example, 2 times already. This is important. Okay. An object is placed in front of your object. Image is formed. This image acts as an object for second lens, which is eyepiece. If image form is exact f, then this lens will produce image at infinity. If it is between f and o, then your image will form, okay, by the side of your object, which is virtual and erect. Virtual image is formed. Anyway, image is very much enlarged. Very much enlarged. In case of observing microscope, what your microscope, there is no need of what is what we call your inverted image makes no problem there. No problem with inverted image. Anyway, what we want to see? We want to see enlarged image. That's all. Okay. Here, let us directly remember what formula for magnification. Total magnification when object, okay, when image formed at near distance, at near distance. When image formed at near distance in case of compound microscope. Once again. Okay. This is m is equal to m naught. I mean m objective, m eyepiece, or m is equal to L by f objective into bracket 1 plus b f what? Eyepiece. F eyepiece. Here, this is expression for what? Magnification in case of is not visible. Number of problems hold all those things. Somewhere I will write here. Or m is equal to this is L by f objective plus into bracket 1 plus b by f. Now see, this is magnification due to objective, L by FO. FO stands for focal length of objective lens. This just before only I just told this expression 1 plus D by FP. Just in case of what? In case of simple microscope, we just derive this equation. Please remember, we just derive this equation 1 plus D by FP. Here D is called near point or least distance of distinct vision. FO focal length of objective. FE focal length of your eyepiece. What is here? L is called tube length. L is called tube length. What is tube length? This distance is called tube length. Which distance? See here. Tube length is distance between second principal focus. Tube length is distance between second principal focus of objective lens to first principal focus. It prepare first principal focus of your eyepiece. Let me repeat. Tube length in case of your compound microscope is the distance between second principal focus. First principal focus will be here. Second principal focus of objective to first principal focus of eyepiece. Let me repeat. Your tube length is defined as it's the distance between second principal focus of objective to first principal focus of eyepiece. Please remember that. Okay? Fine. Now, third optical instrument is telescope. Telescope. Why telescopes are used? Of course, to observe distant objects, heavenly bodies. The first ever telescope, okay, we will discuss it later. That's the thing. There are two types of telescope. One terrestrial telescope and another astronomical telescope. Astronomical telescopes are used to observe heavenly bodies. Correct. How this telescope works? A telescope has a lens here which is called objective, having little aperture. Here, where is the position of object? Object is quite distant, like some planet, some star. A ray of light, a beam of light has to travel longest distance. Your object is at infinity. Your object is at infinity. When, say, a ray of light from any object which is at infinity is incident, we observe this is O. Okay? I will draw somewhere here, right? Somewhere here. The image is formed from where? This is an image. When you place another lens. Okay. What we have? This is image, or let me just extend these rays. I have to draw some. Okay, fine. Your image is formed at infinity. Your image is formed at infinity. Okay. This lens here is called objective. Objective lens. This lens is eyepiece. This second principal focus, which is distance Fe. Okay. This is this is F2 actually. This is Fe. This is the nature of image formed in case of your telescope. In case of your telescope. Remember, this kind of telescope where lenses are used are called refracting telescopes. They are called as diffracting telescopes. They are called as diffracting telescopes. There are two types of telescope. One category where mirrors are used are called reflecting telescopes. Reflecting telescopes. This is second. This is a refracting telescope. It's a refracting astronomical telescope. Astronomical telescope. It's a refracting telescope. Okay? Next. Okay? Let us take B dash, B dash, and H dash. Here magnification, I will write this as important. Okay? Please remember, we write magnification as here somewhere I will write magnification M is equal to focal length of objective divided by focal length of what? Eyepiece. Focal length of eyepiece. Directly please note down. Directly note down magnification. Magnification here is a ratio of what? Objective to its focal length of eyepiece. Okay? So, light beam from distant object when incident on your objective lens, okay, it will form image, of course real image somewhere here, okay. Then by this image acts as an object for second lens, and we observe your final image at infinity. Okay, please just note down. There is one more telescope, just we discussed, called reflecting telescopes. Actually, first ever reflecting telescope was discovered by Dr. Isaac Newton. One more telescope we have to study. The telescope is called Cassidian telescope. Okay, let us study that. Reflecting telescopes. Cassegrain telescope. We have to study Cassegrain telescope. Cassegrain telescope. Cassegrain telescope. These refracting telescopes have some advantage as compared to refracting telescopes. How? First thing, in refracting telescope, there is a chance of chromatic aberration. What do you mean by chromatic aberration? I will explain simply. Okay, it's not very much concern for this year. What do you mean by chromatic aberration? Chromatic aberration means when ray of composite light incident on lens, different colors will meet the principal focus at different point. Here we have blurred image due to variation in wavelength of colors. Different colors, different wavelength make the principal focus. There is not a single focal length. There is some number of focal lengths which are lying closely. So you may be blurred. Chromatic, chromo means color. Chromatic aberration. There also. In case of lens, there is one problem, one more problem.